Here's something almost nobody tells you about water fasting. Around day 2, when there's no food coming in, the bacteria living in your gut don't just quietly wait for breakfast. They get hungry. And they start eating the mucus layer that lines your intestines. That's not a scare tactic, that's what the research actually shows. So today, let's talk about what really happens to your gut microbiome during a 5-day water fast, what bounces back, what doesn't, and why the most surprising finding isn't about the fast itself, it's about what happens when you start eating again. Welcome back to Vegetabla. Before we go any further, I want to be upfront. A 5-day water fast is not a casual wellness trend. It's a real physiological intervention with real risks, and we'll talk about those. This video is here to explain the science, not to coach you through doing one. If you're considering a fast of this length, that's a conversation for you and a qualified doctor. Okay, with that said, the research on fasting and the gut microbiome has exploded over the past few years, and a lot of what's trending on social media just doesn't match what the studies actually found. So let's get into it. Your gut is home to trillions of bacteria, and most of them are in the business of fermenting the fiber and carbohydrates you eat. When you stop eating, that food supply disappears, but the bacteria don't. In a 2019 study by Mesnage and colleagues, researchers used shotgun metagenomics to track exactly what happened inside 6 people during a 5-day water-only fast. Within the first day or two, the community starts to homogenize. Species that depend on dietary carbs like Coprococcus comes, Dorea longicatina, and Eubacterium rectale begin to decline. Meanwhile, more flexible bacteria that can switch fuel sources start to take over. The whole ecosystem reshapes itself around a new reality: no incoming food. Here's where it gets interesting. With no dietary carbohydrates to ferment, your microbiome pivots. A 2025 study in Nutrients showed that carbohydrate degrading capacity drops sharply during long fasts, while the ability to break down glycoproteins, amino acids, and lipids rises. Translation: your bacteria start eating host-derived substrates. That means mucin, the slippery protective mucus layer on your intestinal wall, along with shed cells and proteins. This isn't necessarily catastrophic, and the barrier seems to hold up. Human studies measured markers like zonulin and found that gut permeability stayed stable through the fast. So despite what some corners of the internet claim, a 5-day water fast does not appear to cause leaky gut in humans. But the idea that fasting is just giving your gut a rest isn't quite right either. Your gut is working. In the Buchinger 10-day fasting study by Remely and colleagues, the numbers were dramatic. Protobacteria expanded roughly 6-fold. Bacteroidetes dropped by about half. Firmicutes fell by about 1/3. And one of the most consistent findings across water fasting studies is a steep decline in Fusobacterium, a bacterial genus linked to colorectal cancer. In the Mesnage study, Fusobacterium stayed suppressed in 5 out of 6 participants, even after they returned to normal eating. That's genuinely interesting, but now let's talk about the myth that keeps getting repeated. Fasting boosts Akkermansia. Akkermansia muciniphila is a mucin-degrading bacterium that's become something of a wellness celebrity. You'd think during a fast, when mucin is the main menu item, Akkermansia would explode. It didn't. Human water fasting studies failed to find a measurable increase. The Akkermansia bump shows up with calorie restriction and Ramadan-style fasting, not water-only fasts. Same with butyrate. People claim fasting boosts butyrate, but butyrate comes from bacteria fermenting fiber. No fiber, no butyrate. In fact, the main butyrate producers decline during the fast. This is the finding that reframes the whole conversation. A popular narrative says fasting reduces inflammation. But in the Buchinger study, the inflammatory cytokines IL-6, IL-10, interferon gamma, and TNF-alpha didn't spike during the fast. They spiked 4 days after refeeding. The immune system stayed relatively quiet while people were fasting, and then lit up once food came back. Those markers eventually normalized, but it took about 3 months. And this is the mechanism behind refeeding syndrome, a genuinely dangerous condition where rapid refeeding after a prolonged fast causes sudden shifts in phosphate, magnesium, and potassium. The leading cause of death from refeeding syndrome is cardiac arrhythmia, and the risk threshold kicks in at exactly the length we're discussing: negligible intake for more than 5 days. This is why medical supervision matters for fasts this long. It's not the fast that tends to hurt people, it's the reunion with food. Within days to weeks of refeeding, most of your microbiome composition drifts back toward your baseline. The reset narrative doesn't really hold up. You don't get a new microbiome, you get your old one back mostly. But a few changes linger. Fusobacterium stays reduced, E. coli levels stay depleted. And during refeeding, butyrate-producing Fusobacterium prosnitsa actually blooms, suggesting the benefit isn't from the fast itself, but from the fast refeed cycle together, especially when refeeding includes plenty of fiber. So if there's a takeaway for microbiome health, it's that how you come out of a fast matters as much as the fast itself. I want to be direct here because this genuinely matters. A 5-day water fast is not appropriate for everyone, and for some people it's dangerous. Don't attempt this if you have a history of eating disorders, diabetes, kidney disease, or gout, if you're pregnant or breastfeeding, underweight, an adolescent, or elderly. If you take medication for blood pressure, blood sugar, or lithium, fasting can alter those levels in ways that get serious fast. And if you've lost 10 to 15% of your body weight in the last few months, this is off the table. Even for healthy adults, research consistently suggests not fasting beyond 72 hours without medical supervision. If you're curious about the metabolic and microbiome benefits, shorter protocols, 12 to 16-hour daily eating windows, or occasional 24-hour fasts deliver a lot of the upside with a small fraction of the risk. Please talk to a doctor before doing anything like this. So let's bring it together. A 5-day water fast radically reshapes your gut microbiome, but temporarily. Your bacteria switch from eating fiber to eating your mucus layer and other host tissues. Fusobacterium drops and stays down, which is genuinely interesting. Akkermansia and butyrate do not rise, despite what you may have read. The barrier holds, and the biggest inflammatory event happens after you start eating again, not during the fast. If someone does fast under medical guidance, the refeeding phase is where microbiome care really matters. Slow reintroduction, bone broth, then cooked vegetables, oats, fermented foods, gradually rebuilding the fiber fermenters. The science on fasting is fascinating. It's also more nuanced than the headlines. If you found this useful, hit subscribe. We're going deep on the real evidence behind everything you've heard about gut health. Take care of yourselves, and I'll see you in the next one.